Okay, 11.2. As we discussed in 11.1, it's all about the quadratic formula. Now, since we've used the quadratic formula and we've seen the quadratic formula, this is really going to focus on some examples, solving and using and making sure we're comfortable with it. But also there's a property and a specific thing that we calculate. So we have two objectives. The first objective is to solve equations using that quadratic formula. Using the quadratic formula. And then the new thing that we're introducing here is discriminants. And we're going to talk about how to use them. So just as a little review, our quadratic formula is for the general quadratic equation ax squared plus bx plus c equals 0. Then we know that x is going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. And we showed in the last video where this comes from. Remember, it comes from completing the square on this general quadratic equation. And if we solve that after completing the square, that's where our quadratic formula comes from. So, since we've used the quadratic formula before and we've worked with it, I'm going to give you 3 problems to try on your own. So we have some practice problems. So use the quadratic formula. To solve. I'll give you 3 problems here. 3x squared plus 16x plus 5 equals 0. 3x squared minus 8x equals 2. And I'm writing a little too big, so I'll put the last one down here. 1/8 n squared minus 1/4 n minus 2 equals 0. So again, because we've used the quadratic formula before, I want you to try this out. You have the formula, plug in your values. I'm not going to walk through everything. I'm just going to set up the initial here in a second and then give you the answers so you can check your work. So please pause this video, plug in your numbers, see what you get for all 3, and then you can check what you plugged in versus what I plug in. And if our final answers aren't the same, one of 2 things is happening. Either you've not simplified properly or you plugged in a wrong number. Okay. So now that you have your 3 answers, our quadratic formula for part A, negative b is negative 16 plus or minus the square root of 16 squared is b squared minus 4 times 3 times 5 all over 2 times 3. That's just following our format for our formula. And when you simplify this, you should get negative 5 and negative 1/3. Okay, moving on to B, we do need to rewrite this as 3x squared minus 8x minus 2 equals 0. So following our quadratic formula, negative b is negative negative 8 plus or minus the square root of negative 8 squared minus 4 times 3 times negative 2 all over 2 times 3. And when you finish this and simplify completely, you should get 4 plus or minus the square root of 22 all over 3. Okay, moving on to part C, following our quadratic formula. Negative b is negative 1/4 minus, plus or minus, the square root of b squared is negative 1/4 squared minus 4 times an eighth times negative 2 all over 2 times an eighth. And when we simplify this completely, we get 1 plus or minus square root of 17. That would be our final answer for part C. So if your 3 solutions that you got don't match mine, double check that you have the right things plugged in into the quadratic formula. And if you do, then you need to look through your work and see, maybe you dropped one of these negatives here, maybe you forgot that this was negative and you made it positive here, something like that. It means you have simplification error. Remember, we are fully reducing on part A. You have the plus or minus, and when they're nice numbers like this, that means that this square root was able to be evaluated perfectly. So remember, you do have to split plus or minus when you have just a number and not a radical. Notice we have the radicals here, so we leave the plus or minus notation. Okay, so some problems with quadratic formula. The next thing we're going to do is look at discriminants. Discriminants. So, 4ax squared plus bx plus c equals 0. The discriminant is b squared minus 4ac. So this is the thing that's under the radical in our quadratic formula. And the reason we care about the discriminant is because it tells us what types of solutions we're going to have. So we know a couple things. Number one, if b squared minus 4ac equals 0, well then in our quadratic formula, I'll bring it back in a second, this term goes to 0, which means all we really have is negative b over 2a. And that means that there is one real solution. Only one real solution. Because if our discriminant goes to 0, right, if this thing's gone, there's nothing to plus or minus. So there's not two answers, there's just the one. Second, if b squared minus 4ac is less than 0, well that means that we're going to get a negative under the radical. Then there are no real solutions. Now remember, we just introduced complex numbers at the end of chapter 10, so this doesn't mean that there's no solution, it means that there are two complex solutions. So earlier in the semester when we got no real solutions, we just stopped. But now that we have complex numbers introduced, it's not going to be no solution anymore. It's going to be two complex solutions. You're going to have i's in your answer. And the third case, if b squared minus 4ac is greater than 0, that means that there's going to be a positive under the radical in our quadratic formula. So then there are going to be two real solutions. And these could have radicals or they could not. But this gives us a way to check what our solutions should look like before we jump into the quadratic formula. Now the nice thing is we already have to make this calculation. So if you're solving using the quadratic formula, you're going to have to do this. So if you do it in advance and you simplify it, well, you're just helping yourself out anyway. So there's no downside to looking at the discriminant first. And what you'll find is a lot of times when you're using quadratic functions as models or in the real world, they'll look at the discriminant to understand what the solutions look like before they actually find them. So let's look at a couple examples. So we are going to use the discriminant to determine the number of real solutions and then we're going to solve. So I encourage you to try these out, pause the video as I write them, and try them and see if your answers match up. You know how to do the discriminant, you have the rules right here. You can follow them and see what happens. And we've used the quadratic formula enough. That's all we're going to be doing to solve. So this first one will be x squared plus 3x plus 1 equals 0. So please do try and work this out on your own. Calculate your discriminant, see which case you fall into, 1, 2, or 3. Use your quadratic formula to solve. So we have b squared minus 4ac for our determinant calculation. So this is 3 squared minus 4 times 1 times 1. So this is 9 minus 4, or 5. This is greater than 0. So that means we're going to have two real solutions. And so our quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. This is what I was talking about. If you do this first, you have the simplified version. So you don't just need to plug in the values now, you can plug in the answer. So negative b is negative 3 plus or minus the square root of 5 all over 2 times 1. And so we get x equals negative 3 plus or minus square root of 5 over 2. Or if we want to write it, negative 3 halves plus or minus 1/2 square root of 5. Either of these is okay. And we can see that our determinant calculation saved us a little bit of time, and we know that we should have two reals. Well, this is a real number and this is a real number, so when I add or subtract both of these, we will have a real number, which is exactly what we should have. So that, like I said, there's no downside to doing the discriminant calculation. It only helps you. It gives you a way to check your work. If you don't have two real solutions here, you know you did something wrong either up here or down here. But if you didn't do something wrong up here, it shortens the amount of work you do here, because you're already going to calculate that. So let's try another one. So this would be part B. And let's do 3x squared plus 2 equals 0. So So our discriminant b squared minus 4ac. Now our b is 0. There's no x's there. So this is 0 squared minus 4 times 3 times 2. And so this is going to equal 0 minus 24, or negative 24, which is less than 0. So we know we're going to have no real solutions. And remember, that doesn't mean we have no solution. It just means we have two complex solutions. So when we go to set up our quadratic formula, negative b plus or minus square root of b squared minus 4ac over 2a. We have negative b is 0 plus or minus the square root of negative 24, because we've already simplified it, all over 2 times 3. And so we get plus or minus I times the square root of 24 over 6, which is plus or minus I times 2 square roots of 6 over 6. Can cancel a 2. And so we end up with x equals plus or minus I rad 6 over 3. And that's our final answer. And we match two complex, because we have the positive and the negative version. So let's try one more here. This will take us to the end of section 11.2. So we'll do 2x squared minus 7x minus 4 equals 0. Now, if you haven't been pausing and trying the first two on your own, I highly recommend that you do so now. Pause the video, try this out, do your discriminant calculation, see how many solutions you should get, and then solve it using the quadratic formula. Please try at least this one. Okay, so b squared minus 4ac will be negative 7 squared minus 4 times 2 times negative 4. So this is going to be 49. This is minus 4 times minus 4 is positive 16 times 2 will be plus 32, which is going to equal 81, which is greater than 0. So that means we have two real solutions. So our quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. We already know the simplified version, so negative b is negative 7 plus or minus the square root of 81 all over 2 times 2. So we have x equals 7 plus or minus 9 over 4. So this is where we have to split this, as we talked about, or I said in the last group of examples. This is 7 plus 9 over 4, and 7 minus 9 over 4. So this is 7 plus 9 is 16, which equals 4. 7 minus 9, negative 2 over 4, simplified, negative 1/2. So these are our final answers, 4 and negative 1/2. So I'll write them over here, just because I'm out of room there. Two real solutions, just like our determinant told us. Okay. So again, the discriminant. The discriminant just tells us how many solutions and what types we should be expecting. It also gives us a faster substitution because we've already calculated that, and it's not in this gross fractional form. And then you have something to check your work. As long as you're extra careful on your discriminant calculation, you know how many solutions you should have, you can check that when you get to your end. I have 2 real solutions. I was supposed to find 2 real solutions. Now the one thing this doesn't do, of course, is check your work when you're simplifying. So make sure you're careful on your simplifying like we always have to be. But those are our 2. So now we have 2 ways to solve quadratics: completing the square, quadratic formula. With the quadratic formula, we can do the discriminant. Now you can do the discriminant when you're completing the square as well. It only helps you because you're going to be checking your work anyway, so it still gives you that check. But that's the end of 11.2.